What's up, math scholars and math haters? This is Mr. W. We are continuing with the first lesson on binomial probability. All right, so next I'll pull up the second example, which will be a little bit easier. Now we have 3 trials, and there's a 20% chance of success for each trial. Go ahead and fill some of this in. So let's start with some of the information that we know isn't going to change. 3 is our n. We're doing 3 trials, which means all of these are going to be 3 choose whatever. There's a 20% chance of success for each trial, which tells me first the probability of success is 0.2, and then second that the probability of failure is 0.8. So I'll go ahead and fill those in each spot in the formula where they go as well. Those are 8s. Take my word for it. So now we need to fill in our successes and failures each time. If there's 0 successes, this will be 3 choose 0 times 0.2 to the 0 power times 0.8 to the 3rd power. 1 success would be 3 choose 1, 0.2 to the 1st, 0.8 to the 3rd. 2 successes, 3 choose 2, 0.2 to the 2nd power. Nope, this should be 2. 0.8 to the 1st power, and then finally for 3 successes, that'll be 3 choose 3, 0.2 to the 3rd, 0.8 to the 0. Once again, I'll go ahead and check these. Yes, 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 and yes. Our exponents every time add up to the number of trials, the number of times we're repeating the experiment, and then our probabilities, 0.2 and 0.8, 0.2 and 0.8, 0.2, 0.8, 0.2, and 0.8, all add up to 1. So this is good. This is where we want to be. So let's go ahead and use this formula these 4 times and figure all this out. So we start with 3 choose 0 times 0.2 to the 0 power times 0.8 to the 3rd power. For 0 successes, we have a probability of 0.512. For 1 success, 3 choose 1 times 0.2 to the 1st power times 0.8 to the 2nd, 0.384. And now for 2 successes, that's 3 choose 2 times 0.2 to the 2nd times 0.8, not to the 3rd, to the 1st. That gets me 0.096. And finally, the probability of 3 successes, 3 choose 3 times 0.2 raised to the 3rd times 0.8 raised to the 0, 0.008. And now I'll go ahead and add all these up just to be sure. And I know that I found all these because I typed them into the calculator and added them, and they got me 1. So that's essentially how we use this formula. Oh, there's one more thing. One more quick thing I want to do. I want to focus on this part and this part, 0 successes and 3 successes. Because whenever your number of successes is either 0 or equal to the number of trials, this formula actually becomes a good bit easier to work with. Let's see. Essentially, anything choose 0 is 1. So 3 choose 0 is 1. Anything choose itself is also 1. And again, and when we come to these parts of the formula, there's going to be an exponent of 0 if our successes are equal to 0, or if our successes are equal to the number of trials. Anything with an exponent of 0 is also going to be equal to 1. And I know this is a lot of writing, but I want to just go ahead and highlight one last thing, that whenever we have 0 successes or 3 successes, there's only going to be one exponential expression that we need to find. And just to show how this works, I'll find 0.8 to the 3rd power. Just this part of this whole thing with 0 successes gave me 0.512, same answer as when we use the whole formula. And then finally, I'll do this one down here, 0.2 raised to the 3rd power, and that gave me 0.008, which was the exact answer that we got using the other part of it. That's just a quick little tidbit to make a couple of these easier for you, because there are binomial probability problems where you're going to have to do more than one of these at once like we've done here. But either way, if you are one of my students, best of luck on your assignment. If not, best of luck on whatever work you have to do for this.